In this problem, they have asked us to find out the node voltages, and they already have marked the node voltages for us. See, here is one node, second, third, fourth. Okay, so there are four nodes which they have marked, and they have asked us to find out the node voltages. And they, in particular, have not told by node analysis. Okay, it's very much understood that we have to find the node voltages by node analysis only. We have to find out mesh currents by mesh analysis, right? Similarly, we have to find out node voltages by node analysis. It's very much understood. Okay, next the question is, do we know any of the node voltage? Do we know any of the node voltage? So for node voltage to be known, what is the condition? For node voltages to be known, what is the condition? There should be a voltage source between the node and the ground. And I've not written. Okay, this is 5 volts. This is V4. Everybody get this point? Fine. So there is a voltage source between node 2 and ground. Get that point? Since there is a voltage source between node 2 and ground, which voltage we know? We know V2. That is the voltage at node 2. Okay. And there is another voltage source, but this voltage source is between node 1 and node 3. Get that point? We have a voltage source between node 2 and ground, and we have a voltage source between node 1 and node 3. What does that mean? It means that this V2 is actually 5 volts. Okay, and since there is a voltage source between 1 and 3, we have to combine nodes 1 and 3. Okay, the two nodes we have to combine to form one supernode. So this is a supernode problem. When we go for forming a supernode, when there is a voltage source between the two nodes. When do we know a node voltage? When there is a source voltage source between node and the ground. Get that point? Let's go with the solution. Fine. Here, solution. The voltages they already have marked, so we're not marking it ourselves. By observation, what is true by observation? What is true is V2 is known, that is 5 volts. So what are we not doing at node 2? We're not applying KCL at node 2 now. So number of KCLs have reduced. So how many KCL problem is this? Though there are though there are four nodes, how many KCL problem is this? So four nodes are there, one node voltage I know. So three node voltages are there, but we are forming a super node here. So one KCL to super node, one KCL to node 4. But there are three unknowns. So another equation we have to find comes by the constraint equation. So I need three equations. I need three equations to find out V1, V3, V4. First equation can be obtained by applying KCL to super node, applying KCL to node 4, and by constraint equation. Okay, since this is a super node problem, we have to say that. Okay, what is it? Combine nodes 1 and 3. Okay, nodes 1 and 3 to form a super node. Why again and again? Let me not tell you. Okay, super node, not super mesh. Why? Because there is a voltage source between node 1 and node 3. So how does it look like now? So let me take this, okay, and let me mark that. So this is one node. I've been telling you, instead of looking at two separate nodes, V1 and V3, 1 and 3, okay, we look at a super node. Understand that? So this is a super node. Fine. Since we are having a super node problem, the very first thing that we have to do once we identify the super node is the constraint equation. What is the constraint that we have here? Condition that has to be met to solve the problem. How can you express the 6 volts in terms of the node voltages? How can we express the 6 volts in terms of the node voltages? See, this 6 volts has got positive polarity with V1, negative polarity with V3. So that's why the constraint equation looks like V1 minus V3 is equal to 6 volts. Call this as equation number 1. One equation we have. Okay, let's straight away apply KCL at supernode. Okay, so I'll write that here. KCL at supernode. Everybody count the number of branches at supernode. 1, 2, 3. Only 3 branches. And in all the branches, currents are leaving. Here, no current source, so obviously the current is leaving. No current source, current is leaving. There is a current source and it is showing the current leaving. So all the 3 currents are leaving currents. Everybody is okay with that? So what is the current in this branch? What is the current in this branch? It is V1 minus V2. V2 is already known, right? So we can write V1 minus 5. If you are good with it, if you can handle it, do it. Otherwise, I would rather want you to write it as V1 minus V2 by 10 only. Or if you are aware what you're doing, if you know how to handle this voltage V2, okay, then you can write V1 minus 5 divided by 10. Why minus 5? There is a plus. If there is a minus, it is minus of minus. Okay, so all that stuff we already have seen. So I'll write that as here. Let me write it. V1 minus V2 divided by 10. Okay, if you're good by practice, if you when you get good, you can write it as V1 minus 5 directly to save time. Not a problem. Okay, which is the other current? Which is this current? This is V3 by 1 plus V3 by 1 plus there is a 2 amperes leaving and no current entering. So this is how the KCL at super node looks like. Take the LCM, fine. So LCM is 10 V1 minus V2 plus 10 V3 plus 20 equal to 0. Okay, so this implies what? This implies V1 minus V2 plus 10 V3 is equal to minus 20. Okay, so we have to find the equation with two unknowns now. Here V2 is known, right? So what is V2? V2 is 5 volts. So what we can say is substituting V2 equal to 5 volts. What is it? V1 plus 10 V3 equal to, it becomes minus 5 here. So minus 5, when it goes to right hand side, it becomes plus 5. So it would be minus 15 on the right hand side. Okay, so this is your second equation. So we have equation number 1, equation number 2. Fine. Now we have to find out V4 also. From V1 and sorry, from 1 and 2, we can easily find out V1 and V3, but we need to find out V4 also, right? So for that, what we are doing, we are applying KCL at node 4. Everybody, KCL at node 4. I'll write that here and then I'll take that in an order. Okay. So since the circuit is there, I would like to do it beside the circuit. KCL at node 4. Start doing that, everybody. How many currents? How many are leaving? How many are entering? How many branches first? See here. 1, 2, 3. 3 branches means 3 currents. Since this is the current source showing the current entering, so you have one current entering, that is 2 amperes. This is the current leaving, that is V4 minus V2 by, what is this? Oh, okay, I didn't take that. This is 4 ohms. Everybody take this as 4 ohms. I'm not giving you this resistor. This 4 ohms. So this is V4 minus V2 by 4 and it is V4 by 2. Can you write that, everybody? You don't have to see what I'm doing. I'll just write that here. Okay, you do it yourselves. I'll just be telling it, but you don't have to listen. You can do it yourself. V4 by 2 is one current plus V4 minus 5. We can directly write. Since we're all beginners, I'm doing this V4 minus V2 by 4, and there is a current entering, that is 2 amps. Okay, one current entering, the other two currents are leaving. So this is how it looks like. Fine. So I will take this down. Yeah. So the KCL is here. Bring it to the standard form and substitute V2. Bring it to the standard form and substitute V2. We can substitute here itself. Let's substitute here itself. Substitute V2 as 5 volts. This implies that we have V4 by 2 plus V4 minus 5 by 4 equal to 2. Take the LCM. LCM would be 4. Okay. So it is 2V4 plus V4 minus 5 equal to 2. This implies that we have 3V4. Okay. 3V4 minus 5 equal to 8. So it's 3V4 equal to, so it goes on to the right hand side, it would become 13. So V4 is 13 by 3. What is 13 by 3? V4 is 13 by 3 and that is 4.33. 4.33 volts. So V4 we got first. So how would you find out V1 and V3? How would you find out V1 and V3? See here, V1 and V3 can be found out by solving equation 1 and 2. So solving equation 1 and 2, solving equations 1 and 2, what we have is this. V1 is 4.091 amps. Sorry, volts. It's a voltage. Anybody with V3? Anybody with V3?
Minus 1.909. 1.909.
Yeah, that's correct. Minus 1.909 volts. This is how we find out the node voltages. Okay, so this is what I wanted to give you. Now let's move on with another problem, that is this. Okay. The 10th one, we will stop solving the problems after this. Okay, for node analysis. Fine, I'll give you the assignment again. Fine, you can do the assignment. So what is being asked here? See, they are asking us to find out current I naught by node analysis. Now the challenge here is to identify the non-reference node. Which are non-reference? This is a reference node. You're not counting this. If this is a reference node, this is also ground, this is also ground. So all the 3 points are ground. So these points you're not marking. So except this, how many other points are there which we can consider as nodes? So this is one node, 2, 3, 4. So totally there are 4 nodes now. Okay. They have directly asked us to find out I naught by node analysis. So it is our responsibility to mark the nodes. Everybody's okay with that? Let me do that. Okay. I can mark my V1 here, V2, V3, and V4 here. You can take down the circuit fast. Okay. Now, you need not have to name it this way only. You can rather say this is your V1, V2, V3, and this is your V4. You can say that. Not absolutely no problem. Fine. So what do we know by observation here? Do we know any node voltages? Everybody look at this and answer this question. Do we know any of the node voltages here? When do we know a node voltage? When there is a voltage source between a node and the ground. When there is a voltage source between a node and the ground. Where are the voltage sources? See, here is a voltage source. So this voltage source is between node 4 and ground. So I know the voltage at node 4. This voltage source is at node 2 and ground. Okay, that's why I know the node voltage V2. So by observation, let's write these two first. Okay, so let me say that. First you have to say mark V1, V2, V3, and V4. So after marking, we come to know that by observation, we can say our V1. What is V1 there? See, negative sign is with node 2. So this is what one needs to be careful regarding the polarities. So minus is there with node 2, plus is there with the ground. So what is V2? V2 is minus 12. But see V4, the positive sign is with node 4. So V4 would be plus 24, whereas V2 would be minus 12. Okay, so you need to be very careful regarding the polarities. So this is minus 12 volts, mind you. Okay, very important.
V2, sir.
This is V2. Yeah. This is V2. Exactly. Now, similarly, V4. V4 is 24 volts. Fine. How many KCL problem is this? We have marked 4 node voltages. Among 4, we have come to node 2. So 2 more voltages need to be found out. That means there are 2 unknowns. So where from I'll get the 2 equations to find those 2 unknowns is the question. Okay, so V1 and V3 are the unknowns. How do I find out V1 and V3, and how do I get those 2 equations to find V1 and V3? Anybody? There are 2 equations, sorry, 2 unknowns. I need 2 equations. Where from I'll get those 2 equations? is the question one should answer. See here, there is a voltage source between node 1 and node 3, which means that I can form a super node between 1 and 3. So combine 1 and 3 to form the super node. Let's form the super node now. How does it look like? See here, take this, combine them. So it became a super node again. So this is a super node. So say that what? Combine nodes 1 and 3 to form super node. As shown, you can say, as shown, we already have shown, right? As shown, we will do this. Now, two equations I need. Where from I'll get those two equations? One equation I'll get by applying KCL at super node. And since this is a super node problem, another equation is the constraint equation. Both in case of super mesh and in case of super node, we write the constraint equation. So you should not forget that. Otherwise, we'll find one equation short. Okay. So what is the constraint equation here? Constraint equation. What is that constraint equation? It is V1 minus V3 because V1 has got the positive polarity connected to it, and this is 24 volts. Call this as equation number 1. We need another equation. So that equation I'll get by applying KCL at supernode. KCL at supernode. Now, how many currents at supernode? See here. 1, 2, 3, and 4. There are 4 currents. Among the 4 currents, do you find any current entering? No. Why no current entering? There is no current source showing the current entering the supernode. So there are no entering currents. We have 4 branches, 4 currents, and all the 4 currents are leaving currents. Okay, they are leaving the supernode now. So which are those currents? Let's start here. V1, okay, minus V2 by 2. Okay, then V1 minus V4 by 2. So from node 1 side this, and we have to write the same from node 2 side, node 3 side. What is it? It's V3 minus V2 by 2. Okay, then plus V3 minus V4 by 2 equal to 0. Okay, now just bring it to the standard form. KCL, the LCM is 2, so you'll not have any problems doing. Okay, so how does it look like? So how many V1s there? 1, 2, 2 V1. How many V2s? Minus 2 V2, then plus 2 V3, then minus 2 V4 equal to 0. This is how the equation looks like. Now V2 and V4 we know. Substitute V2 and V4. Okay. So V2 is minus 12, mind you. V2 is minus 12. So let's write that here. Minus 2 into minus 12 plus 2V3 minus 2 into 24. This is how the equation is. So how this would reduce now? This would reduce to 2V1 plus 2V3. What do we have on the right hand side? It's 12 to the 24 plus 24 would become minus 24 here. Okay, and this would become plus 48. Okay, so it is plus minus 24 plus 48 would give you plus 24. Okay, so let's write that. Plus 24. Hope I'm correct. If I'm wrong, let me know. Okay, no problem. This is our second equation. So solve 1 and 2, everybody. Solve 1 and 2 to get V1 and V3. So solving 1 and 2.
And minus 6.
Yes, V1 is
18.
18.
18.
Okay, the others can cross check this. V3
Minus 6.
minus 6.
Minus.
Okay, good. Fine. Now, what is that they've asked? Till now, we just did finding node voltages because we were asked to find out I naught by node analysis. So node analysis means we need to have node voltages in hand first. Then after finding out the node voltages, what is I naught? Anybody can you tell me what I naught is in terms of the node voltages? Anybody? How can I write I naught in terms of the node voltages? So I naught is leaving node 1, right? I naught is leaving node 1. So since it is leaving node 1, I would say it's V1 minus V2 by 2 is your I naught. Okay. Therefore, our I naught is, what is our I naught? It's a V1 minus V2, V1 minus V2 divided by 2. Get me this? What is B1? B1 is 18. V2 is minus 12. So it would be minus of minus. Minus of minus 12 divided by 2. So it is 30 by 2. So this implies that I naught is 15 amps. Everybody get this? So this is how we can solve the problems.